So, good morning to all. Today we will start a new topic that is clustering techniques. On the first class I talk about the different tasks of data mining. So, earlier we were talking about the classifications and now we will talk with clustering techniques. So, we will review what was the classification definition, that is the task of classification is to assign an object into one of the predefined categories. So, that is we know, and then how it works, that we know that it will have a training set. So, that is a set of object with their categories are provided. So, that is something called the training set, and then we will make a model using this training data set, and whenever new object comes or unseen object comes, then we have to assign any one of the predefined category. So, that was the working principle of the classification techniques, and then we studied various classification techniques, and classification technique support vector machine will be covered very shortly. And then other example of classification techniques that we talk about, that is predicting tumor cell as non malignant or malignant, classifying email as spam and non spam. And similarly, categorize the news article as finance, weather, entertainment and sports. This is all about the classification problem, and you know all of them. But problem with the classification task is that it needs the training data set. What is training data set? So, each object should be labeled what is what. So, predefined classes, any one of the predefined classes should be assigned to the each instance in the training data set. So, as I said earlier also, and then most of the cases this classification, this training data set is built by the human being, and then there is a high chance of error, and maybe in new applications it is really difficult to give the label or get the label training data. So, this is the major drawback of the classification problem, that is the non availability of the proper training data, and it is difficult to have the correctly labeled data in many applications. So, we have the data, but we do not know the class level. So, in that scenario what should we do? So, that is something called the clustering technique will help us. So, therefore, in summary, clustering technique works in absence of the training data. We have the data, but we do not have the label. So, in that case the clustering technique will help us. So, there are plenty of clustering techniques. So, we will cover very popular approach starting from the very initial clustering approach, and then we will cover latest clustering approaches in this class. So, before that we will go the formal definition of the clustering. So, here is the formal definition. Cluster analysis or clustering, I will give the first definition, that is the cluster analysis, and there is clustering and cluster analysis is same, and then I will introduce later on one more term that I will clarify later. So, that is cluster analysis is to discover the natural grouping of a set of pattern, points and object. So, what is the, because we do not have the class level. So, what we can do it? So, cluster analysis will do discover the natural grouping of the objects in the data set. We have the data set. So, what it will do? It will make the groups of the data set. So, the first definition, as you see that reference quietly said, is that first definition is given by the A.K. Join, scientist A.K. Join, that discover the natural grouping. So, now natural grouping, it is really difficult to say how to define the natural grouping. So, say let us say some scene I will say is very beautiful, some other guy may say it is not that much beautiful. So, that is the natural, the word natural is kind of fuzzy word. So, therefore, with this definition it is really difficult to work out, say especially doing some kind of computations is really difficult with the definition, that is the making the natural grouping of the instances, which is natural to me may not be natural to you. That I said the one example. I said is this student is really excellent. So, his fellow student will say he is not that much excellent. So, therefore, natural word is very vague word, and it is really difficult to work with this definition. So, therefore, the second definition is widely accepted and it can be processed by the computer system. What is that? That clustering activity or cluster analysis is to find groups of pattern or objects, and this group of pattern we say is the cluster. And we will make this group in such a way that objects or pattern in a cluster are more similar to each other than pattern in a distinct clusters. So, this is something I will explain more details, but let us see here what you have to do. We have the data set, but we do not have the class level as I said, and this is because absence of the class level. So, this type of clustering, this type of task is called the unsupervised, because there is no supervisor to guide the algorithm. So, therefore, this is something called the unsupervised learning, because in the training data set when you make the model. So, when you make the model in classification techniques, we have the supervisor to tell. So, this pattern belongs to which category, but in case of the clustering there is no supervisor, there is no training data set. So, therefore, this is called a unsupervised learning. So, there are some other unsupervised learning we will know later on, say outlier detection is other unsupervised learning. Now, we will go back to the definition number 2, that is the clustering activity or cluster analysis is to find the groups of patterns called the clusters. So, then you make a group of pattern and then each group is called cluster, and what is the characteristics of this cluster? If you take any object within a group, that will be much more similar than if you take the two objects from the two different groups. So, what I said is, suppose you have the data set here and you have a point here. So, now you make a group like that. So, you have a one group and maybe you may have another group, and if you see similarity between this object and this object is more compared to if you take this object x I and another object say let us say y I. So, that is the term here. So, we used that is the group of pattern is called cluster, and the patterns in a cluster, that is pattern you can replace the word objects. Objects in a cluster are more similar to each other than pattern in the distinct cluster. So, if you compare two objects from the two different groups, that will be dissimilar with compared to two objects in the same group. Now, if you see the definition here, so we know what is cluster, group of objects form a cluster, and then there is two patterns in a group or two objects in a group are similar, and we have the notion of similarity. So, we can compute the similarity between the objects and then we can find the group. And unlike this natural grouping, it is very difficult to do any computation with this definition, that is natural grouping. So, the second definition is widely accepted, because we have the way to compute the similarity between the objects. It may be within the cluster or across the clusters. So, therefore, this definition is well accepted. We will see one more definition similarity. So, similarity we know that we have already we computed the similarity between a pair of objects, because in earlier case what we have to do, similar object we put in a group, a dissimilar object we put in the different group. So, that was the main objective, main motto of the clustering techniques. So, therefore, we should have the tool to compute the similarity between a pair of objects. So, therefore, the similarity between a pair of patterns or objects. So, this you can replace by objects or patterns or instances, and this is nothing but a function from, and it will varies from the 0 to 1, that we know and we study earlier. And we also know that closer the value, that similarity value to 1, that is very likely that those two objects are very similar, and if it is 1 exactly, so it is the identical object, two objects are same if the similarity value is 1. And then we study something called simple matching earlier. So, just and then we studied the Jaccard coefficient. Okay. So, Jaccard coefficient, let us say we have the two objects, let us say x and y, it can be binary or it cannot be also binary. And then how do we compute the Jaccard coefficient? wherever both are matching. So, let us say this is one and then rest of the thing are not matching. So, therefore, Jacquard coefficient is something wherever this is matching and then. So, Jacquard we studied Jacquard between A and B is A intersection B by A union B, that is we studied earlier. So, this is Jacquard. Similarly, we studied the cosine similarity. So, suppose you have the object x and y, how to compute the similarity between two documents. So, we computed the cosine similarity. Not only that, we also compute the dissimilarity. So, one example is the Euclidean distance. So, Euclidean distance is a kind of dissimilarity measures and this is the Euclidean distance, okay. And this is something called generalized Euclidean distance. So, if you go back the definition, so definition says that you group the objects, clustering definition I am talking, the second definitions. You group the objects, you put the objects in a group and that is something called cluster, such a way that objects in a group are more similar than the objects from the two different groups, okay, that is we said. So, we know the similarity measures, we know the dissimilarity measures and then we should able to apply the clustering technique on the data set and data set is does not have the class level. So, one more definition of clustering. So, this is something called the set theoretic definition. Let us say DV is the data set. So, D is having the object say let us say x 1, x 2 to x n, that means there are n instances or n objects and each object is having features. Let us say if you talk about the classification example here. So, loan, that is typical table, we have that whether this guy is married or what is the income and these are the features, okay. So, each row itself an object. So, x y x I, each x I represent one row in the example table earlier we studied. B a set of pattern called data set, that is we know, where each x I is a pattern of the n dimensions, okay. And each x I there is this n and this n is different, okay. So, it is n dimension means n features. So, each object is having n features. Now, what is clustering? Clustering is nothing but the partition of the data set. So, a clustering pi of the data set can be defined as follow. What is that? So, pi can be defined as C I, C 2, C k. What is C I? Sorry, what is C 1, C 2, C k? What is C I, C 1, C 2, C k is the each one is the cluster. Earlier we studied what is cluster? A group of object is called the cluster, that is definition we studied, right. So, each C I is nothing but the each C I is a cluster, a group of objects. So, then we will get a number of cluster k. Okay. So, how to define the value of k and so we will know later. Okay. So, then entire data set will be divided into a number of groups or number of clusters and then what is the conditions? When you again make the union of the all groups, then you will get the original data set, okay. And no cluster can be null. So, at least there should be one point in each cluster. And another definition is what? Another definition is here is if you take the intersection of the two groups, you will get the null. So, there should not be any common element between the two groups. So, these are the very classical definition, but we will study little later if you have a time. Sorry, we will study later is there is something called fuzzy clustering, where there may be a common member between the group, but this is a very classical definition. Okay. This is not the end. What is that? Similarity between two objects in a class in a cluster will be more than the similarity between two objects across the clusters. Let us say x 1 and x 2 is in a cluster. So, similarity will be more, and if x 1 and y 1 are x 1 is here in C I and y 1 is in C j. So, if they are two different clusters, then similarity value will be less with compared to the objects belongs to same group or cluster. This is set theoretic definition. Now, we know the definition is in summary. You are giving the data set, you have to make the groups in such a way that objects within a group will be the similar, much more similar than objects across the groups. So, this is the summary of the clustering definition. Now, what you do it? How we will achieve this objective, that is making the group? What is the objective? Objective is making the groups. Now, there are plenty of clustering techniques that we will study. Some popular clustering technique starting with initial days, and very popular clustering technique is the K-mean. Okay, you must have studied in somewhere, but again we will study here. So, before that we will start with a very simple clustering techniques, and then we will go to the latest clustering techniques. So, what is the application domain in the clustering? So, clustering has been applied to the genomic data to group the functionally similar gene. Even we can apply the clustering technique on the students in a class to identifying some characteristics of the students. Let us say we can identify, we can group the student whether the students are professional or students are non-professional, but that is if you know the level, then obviously that will become the problem of the classification. But if you do not know the level, even not for a single student, we do not know who is the professional or not, then we apply the some based on the features of the students, then we apply the clustering technique and we find the level. Sorry, we find the groups, we cannot find the level, we find the groups of the similar students. Similarly, information retrieval. So, search result obtained by the various search engines such as Google, Yahoo can be clustered, so that the related document appear together in a cluster. Okay. Once results you obtain, so we can put them into similar cluster. We have something called Google News. I think you must have seen there is something called Google News, right. So, Google News put the related documents of all sports news in a similar cluster, and then they say it is this cluster is something called the say news document, sports news and so on. And then market research. So, entities, people, market organization can be clustered based on the common feature of the characteristics, and then there is application of the image processing, web mining and so on. Okay. Next we study the clustering techniques. So, as I said, clustering, first clustering was clustering task or first clustering algorithm was introduced in the mid of 50s in the last centuries. Okay. So, you can imagine more than 70 years, and there are plenty of algorithms invented over these 70 years, and still people are inventing the algorithm, that is clustering techniques are introduced. You can imagine that every year maybe more than 50 algorithms are introduced from the different part of the world. Okay. So, because the problem is so difficult, okay, because that again similarity measure, there are plenty of similarity measures. Okay. If you apply the one similarity measure across the domain, so one similarity measure, let us say the cosine similarity measure is good in the document, but that may not be good in say let us say in other domain. So, therefore, when you change the similarity measure, you may obtain the different results. So, these entire clustering techniques, that is clustering techniques or clustering algorithms can be classified into different angles, okay, where they someone use the local criteria, someone use the global criteria, okay. Someone only one clustering algorithm gives one single partition, some clustering algorithm give multiple partitions and so on. So, here what you do it, first clustering algorithm can be divided into two categories based on the how many partition it provides. Now, we will clear two terms, say I am saying clustering techniques, okay, or cluster analysis. Similarly, when we the results is also called the clustering. So, let us say we have the data set as I said x 1, x 2, x 3 and say x 10, only 10 objects. Now, you apply, say let us say you apply X clustering techniques, I use the word clustering technique. Okay. Now, you get a partition. So, let us say this is a partition pi 1. So, this one clustering technique can give the results as I say C 1, C 2, let us say C 3. What is C 1? C 1 is a group of objects. So, instead of C 1 what we can write it, obviously we can write C 1, but again we can write let us say x 1, x 10 and let us say x 2. Okay. So, this is let us say C 1 and then another may be x 3, x 4, x 5. Okay. So, this may be C 2 and rest will be the objects. So, let us say this is C 3. Okay. Now, this is as I said this is something called the cluster, but this result entire result that is pi 1 is called the clustering. So, pi 1 is called clustering and then C 1 is called the cluster. Do not get confused. Okay. So, the entire results is called the clustering or partition and this individual group is called the cluster and technique is also called the clustering techniques. Okay. So, two terms, one is cluster is group of objects, clustering is entire partitions of the objects. So, this is something called a single partition. So, some other clustering technique can give results let us say pi 2 is x 1, x 10, x 2. So, x 1, x 5 and x 11. So, this is C 1 and C 2 is something else x 3, x 10 and so on and so on. So, this is a different partition or different clustering. So, this is also pi 1 is on clustering, pi 2 is another clustering and you can get the another clustering based on the output of the different clustering algorithm. Okay. So, then two terms, one is cluster is this one and clustering is the partition of the data is called the clustering. So, this pi is nothing but the partition of the data. What is the partition of the data? That set theoretic definition, if you take the intersection of the two clusters you will get the null. So, there should not be any common element between them and if you take the union of the all clusters in a clustering you will get the original data set. Say here if you take C 1, C 2, C 1. So, if you take the union C 1, C 2 and C 3 that should be the D, the original data set. Now, I will come to the classification of the algorithm. There are plenty of clustering techniques as I said and these clustering technique can be divided two major part. One is if a clustering technique gives a single partition, then this is something called the partitional clustering. Single partition means either it can produce pi 1 or it can produce pi 2, not both. So, now we will look into the definition here. Partitional clustering creates a single clustering of the given data. Single clustering means you can consider pi, then C 1, C 2, C 3 and C k and so on. Now, what is the characteristic? Let C 1 and C 2 be the two clusters in the clustering. What is that? There should not be this relation, that is two clusters cannot have the relationship superset and subset. And then if you take the intersection then you will get the null. So, this is something called the partitional clustering. So, partitional clustering you will get single clustering and these two conditions will be satisfied. What is these two conditions? C 1, C 2 if you take the two clusters it should not be this kind of relation, that is superset subset relation is not there. So, let us say we make more simple example x 1, x 2, x 3 and then x 4 and x 5. So, now I get a partition pi 1. So, first cluster is x 1, x 5 and x 4 and second cluster is x 2 and x 4. So, this is a clustering So, we are getting single clustering. So, this can be a partitional clustering according to this definition, it creates a single clustering of the data set. And now, you take this is C 1 and C 2, there is no set and subset superset relationship, this is satisfied, and then if you take the intersection it will be null. So, this is an example of the partitional clustering. If any clustering technique produce single clustering with these two conditions, then we will say it is a partitional clustering technique. Now, there is something called hierarchical clustering methods. So, it produce multiple clustering, it can produce x 1, x 2, x 3, sorry it can produce pi 1, pi 2, pi 3. So, it can produce the multiple clustering, and what is the relationship? Hierarchical clustering method creates a sequence of partitional clustering of the data. That means, each pi 1 will be a partitional clustering, but it will produce multiple clustering. Let us say this is pi 1. So, it produce pi 1 and then it produce pi 2, it produce pi 3, but each pi 1 is each pi I is a partitional clustering. This is one example. So, you have the data set. So, you get one clustering. So, that is the this red is forming one cluster and this is forming two cluster. This is highly possible, because we do not have the, because we this red color and blue color we put this color, but we do not know the class level. So, when we apply the clustering techniques, we ended up with the 3 clusters. So, if you want the 4 cluster, we can ended up with the 4 clusters, because we do not know actually how many classes are there, because we do not have the level. So, based on the requirement of the users and based on the algorithm we used, it can produce also the 4 clusters or 4 groups. So, this is one example of the hierarchical clustering. So, you had same data set, now you apply one hierarchical clustering. So, this is pi 1 and this is pi 2. So, this is pi 1, why? If you take the intersection, so this is the one cluster and this is another cluster. If you take the intersection, so there is no common and there is no subset superset relationship, and this is another, this is also partitional clustering, because if you take the intersection of any two cluster, you will not get common and there is no subset superset relation, but this is one thing to be noticed. So, there is one single cluster and then this single cluster again divided into 2 clusters. So, between the 2 clusters across the clustering, in hierarchical clustering approach, you have the subset superset relation, because this is the subset of this one and this one is the superset of this cluster, but within a clustering there is no such relation. I am saying across the clustering, this is one clustering, this is another clustering, within the clustering it is a partitional clustering, but if you take the relationship across the clustering, so this type of relationship will be there in case of the partitional clustering, in case of the hierarchical clustering. So, we will show the example, because we will apply different clustering techniques, and some clustering techniques is hierarchical and some are partitional clustering. So, today class we will start with one easy partitional clustering approach. So, this algorithm was introduced maybe 70s or 60s. This is something called the partitional clustering approach obviously. So, this is algorithm name is BSAS, Basic Sequential Algorithmic Scheme. So, BSAS needs 2 user specified parameter, that is distance threshold and the number of cluster. Distance threshold means we will be using here the Euclidean distance, and how many cluster I want from the out of this data set, that you have to specify by the users. So, that was the initial algorithm. So, later state of the art algorithm does not need this number of clusters, the user has to define. So, these are the initial clustering. So, it needs 2 parameters. Then how it works, this is the algorithm here. So, what we have? We have the data set. So, we have to form the clusters, right. We have to find a single partition, because it is a partitional clustering method. So, how do you do it? The input is given the some distance threshold tau, and another is how many cluster we want. So, number of cluster, this is 2 information are given. What is that? First I equal to 1 and first cluster you form, that is forming the cluster, first cluster is the first point in the data set. So, this is x 1. Now, apart from the x 1, x 1 is already assigned to a cluster. So, now we will try from the x 2. What do you do it? Find the nearest existing cluster C min such that distance from x to C min is the minimum from the all existing clusters. So, what you do? There is only one cluster here. Now, what we do? We compute the distance from x 2 to the cluster, we compute the distance from x 2 to the cluster C 1. Now, if there is another cluster C 2, we compute the distance from again x 2 to C 2, and which one is the minimum, we will identify that cluster. So, that is it says find the nearest existing cluster C min. We have 5 clusters and we have to assign this cluster x to one of the 5 cluster, or it will form the new cluster. So, we compute the distance from x 2 to the all cluster and find the closest cluster. Once we found this closest cluster, then we found the what is the distance from the point x 2 to the closest cluster, that is already we must have computed in this step. If this is greater than tau threshold distance, what is the threshold distance? That means, any point within the threshold distance, if any cluster is there, so that point will be assigned to the closest cluster. So, if distance between x to C min is greater than tau, that means, we cannot assign the point to the C min cluster, it is away from the cluster, as we said the similarity dissimilarity measure. So, here distance is used as a dissimilarity measure, and number of cluster is less than k. So, it did not reach to the maximum number of clusters. So, in that case what you can do, this will be the x 2 will be the new cluster. So, x 2 will be the new cluster. What we basically we are doing? So, when new objects come, we will compute the distance from the new object to the all existing clusters, and we will find the closest cluster. Okay? And if this done, that is the closest distance is less than tau, so then you are done. So, you assign the point to the cluster. If it is not, so if the distance is greater than tau, that means it may be the new clusters, and obviously you have to see the number of clusters is already reached the point or not. So, if that is not the case, then you form a new clusters, otherwise you assign the point to the closest cluster itself. So, that is something called the BSAS scheme, basic sequential algorithmic scheme. Now, you move to the third point x 3. Now, what you do? Same thing, you compute the distance from x 3 to C 1, you compute the distance from x 3 to C 2, and which one is the closest? You find this closest one, and let us say closest is this one, but this distance is greater than tau and number of k is 3. So, therefore, x 3 will form a new cluster. So, C 3, so x 3 will form a new cluster. Now, you go to the next point. So, let us say x 4, you compute the distance from x 4 to all C 1, C 2, C 3, and you find that C 1 is the closest one, and distance from x 4 to C 4 is greater than tau. So, it depends, it should be a new cluster, but k value is 3. So, we cannot form a new cluster, then x 4 should be assigned to the with x 1 and x 4. Now, you go to the x 5, you compute the distance from x 5 to C 1, you compute the distance from x 5 to C 2, distance from x 6 to C 3, x 5 to whichever is the minimum, and if it is less than tau, then you assign. If it is greater than tau also, whenever is which cluster is closest one, you assign that point. Let us say x 5, you assign x 5 here. Okay. Again you go to the x 6, again you compute the distance from x 6 to the all clusters, and you find the minimum clusters point, minimum cluster, and if that distance is greater than tau, also you assign. If it is less than tau, you assign to the closest one. So, this is something called the partition or basic sequential algorithmic scheme, and you keep on doing until unless all points are assigned to any one of the clusters. So, finally, you will get clustering like by let us say C 1, C 2, C 3. What is the advantage? Advantage is it is a single data set scan. So, each point you are taking and directly you are assigning the any one of the cluster, you are not again looking that point. Okay. This is something called is a very fast approach, as you see the time complexity is linear, number of cluster is generally very less than the number of points. So, complexity will be the linear algorithm. What is the disadvantage? So, beforehand you have to say how many clusters are there, and results is not very good if you compare with the today's state of the art clustering approach. So, I stop here.